Hey guys, this lesson we're looking at systems of linear inequalities. So let's start talking about linear equations real quick. Y equals mx plus b. M is the slope, b is the y-intercept. You start at the y-intercept. And then you use the slope. Remember, slope is like rise over run if it's a fraction, and everything is a fraction. If it doesn't look like a fraction, it means the denominator is 1, so it'll be over 1 if it's not a fraction. So let's just quick review how to graph a line, because that's what we're doing. But now we're looking at inequalities, which means we could have y is greater than, or y is greater than or equal to, something like that. So we're going to look at those four things. So let's start the difference between the greater than, less than, or the greater than, equal to, less than, or equal to. If it is or equal to, we're going to be graphing a line. It's a solid line for these two. And if it's not equal to, then we will be drawing a dashed line, or dotted. So our line would look like these. So that's the first part. Dashed line or dotted or solid line based off of or equal to or not or equal to. The second part is which way do we shade. So when we are graphing greater than, we shade above the line. Greater than is above the line. So when I do these, I just start at the line and I just draw straight up from our solid or dashed line. And that's the side that we're talking about. When it's less than, like these bottom two, you start at the line, whether it's solid or dashed, and you just go straight down. Less than would be down. Greater than would be up. So that's the beginning part of this. We're actually going to jump ahead. We're going to look at examples 7, 8, and 9 first, because it's kind of actually the last step of what we do, but once you get that, it makes everything else pretty easy. So the maximums and minimums, we've done this before. We've done it with parabolas. We've done it with some word problems that resulted in parabolas and things like that when we talk about maximums and minimums. And the thing, when we go back to parabolas, maximum or minimum always happened at the vertex of the parabola. It still will always happen at the vertex, but now on these lines, a vertex takes on another meaning. Vertex is also the intersection of two lines. So all of these dots that are drawn in here, these are all vertices. Each one of those dots is a vertex. So maximums and minimums happen at vertex. So when we're trying to maximize, we're looking at the four vertices. So our first vertex is, we'll take this one right here, 0, 0. Our second vertex, let's go here. This would be, check your scale before you just write down a number. This is 6 labeled out here, which means these are counting by 2s. See, it's 6, 8, 10. So this would be 2, 0. So then point C over here, that's between 2 and 4, so we're going to call that 3. And then our Y value there would be 5. And then this last one, point B up top, that is at 0, 10. So those are our four vertices. So what we're going to do is we're just going to plug those into the equation. So when we plug in 0, 0, we get P equals 0 plus 0 is 0. plug in 2 and 0. So we plug in 2 for x. 2 times 2 is 4. 0 times 3 is 0. We get 4. Now we're going to plug in 3 and 5. 3 for x. 2 times 3 is 6. 5 for y. 5 times 3 is 15. Add those up, you get 21. And then plugging in 10, 0 and 10, so we get 0 plus 3 times 10 is 30. Now, it's a simple, we're trying to find the maximum, we're just looking at the numbers now. Since we're trying to find the maximum, to maximize the equation, find the biggest one, 30. And then we just got to answer it in context here. The maximum is 30. And we'll say at the point 0, 10. Now, if this was a word problem, 0 and 10 would probably represent something. Maybe it's sales of 2 different things or whatever. So you'd sell none of the first object and 10 of the second object, whatever those were. So that's it. We're looking at the vertex, because maximums and minimums always happen at the vertex. And you plug in those coordinates to the equation to get the maximum or minimum. Now, in word problems, P usually is going to stand for profit, which makes sense. You want to maximize profit. C would stand for cost. You do want to minimize costs. You want to make the most money for the least spent. That's business. So, here we go again. Vertex. We've got 4 of them, A, B, C, and D. So A right there, that's at 0, comma, again, we're counting by 2, so 0, 3. B is at 2, 7. C is at 8, 3. And D is 4, 0. And then we're plugging those into this equation right here. X plus 2y. So plug in 0 and 3. We get 6. Plug in 2. And then 7. 2 times 7 will be 14. Add it up. You get 16. Plug in 8. That's 8. Plug in 3. 2 times 3 is 6. 8 plus 6 is 14. And then plug in 4, 0. That'll be 4 plus 0 is 4. So again, max or minimize this time. So we're looking for, yep, the smallest number. 4 is the smallest. So this is our minimum. We have a minimum of 4. And that happens at the coordinate 4, 0, which is point D up there. This would be the same sort of setup. I'm going to leave it for you to do on your own. Just get our 4 vertices, plug them in, and then choose the largest one that is your maximum. So now we're going to look at problem number 1. Working a little bit backwards on our worksheet here. We just have to start. Remember our goal, we have a blank graph here. Our goal is to make a graph and then take each of the vertices and figure out what is our maximum or minimum into our equation. So we're looking for a minimum of this cost equation after we graph these. So in order to graph, we need, this first one was, you can either make it be y equals mx plus b, or you could graph in standard form, which is what this is. Doesn't really matter. If you're more comfortable taking it to y equals mx plus b, you would subtract the x over and then divide everything by 2. So you get 1/2 x, and that would be 3. So start with this y-intercept of 3, and then our slope is negative 1/2, which means down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2. If you didn't go to slope-intercept form, if you just did from standard form, the easy graph is you plug in 0 for y to get x equals 6. That's your x-intercept, x equals 6, right here. And then you would plug in 0 for x to get your y-intercept, and you'd have divide by 2, you get y equals 3, and that would be your y-intercept up there. And then straight line to graph the rest of it. Okay, so we have that line. It was y is less than or equal to, which means it's going to be a solid line because it's or equal to. Solid line, you said. And when it comes to shading, it was less than, which means we're shading the down, bottom side of that, straight down from this line. All right, but that's only one of the 3 equations we have. Our other 2 equations, x is greater than or equal to 2. So x equals 2 would be a line that goes through x equals 2. So here's x, here's 2, straight line through that. And all of these are solid lines. So a straight line through 2 is going to go straight up and down. And it says greater than 2. So when you're talking x is greater than 2, it would be to the right of this. So you've got some options then. You can erase anything on the left, or you can just start shading. This would be to the right. And we're looking for where we shaded with all the different colors or lines or however you're shading. Really, colors is the way to go with this. Highlighters, colored pencils, something like that. Colored pencils would probably be the best. In case you mess up, you can erase. Or crayons. Crayons erase a little bit. You could try that. Alright, and then our last one here, we'll use green because I haven't used green yet. Y is greater than or equal to 1. So we go to y is 1 on the y-axis. Solid line straight through that because it was or equal to. And our inequality was greater than, which means we're going to be going straight up from there. Alright, so we're looking for areas that have all 3 colors. So it has to be inside the blue, so to the right, above the green, so up, and below the red. So that's going to actually just be this region right here. So that purple region right there. So for that, we have 3 vertices, 3 corners right there. I did those in black to make those pretty visible. So our vertices are 2, 1, 2, 2, and that is 4, 1. And we're plugging each of those into our equation, 3x plus 4y. So 3 times 2 is 6, 4 times 1, that's 10. 3 times 2, that's 6. 4 times 2, that's 8, so 14. 3 times 4 is 12. 4 times 1 is 4, that's 16. And we are looking for a minimum. Smallest number is 10, happens at 2, 1. So the minimum is 10, and it happens at the point 2, 1. So this has a lot of business sort of applications. You have different lines, different equations for maybe objects you can sell or things like that, and you're trying to maximize profits or minimize costs. Lots of business applications to this sort of thing. So go ahead and finish up this worksheet. We did a couple of them together here. That was your notes. Finish it up and get that submitted. See you next time.